And now it's time for a Geek Speak with GK Technologies, Sarah and Jody.
In the fields again. I just can't wait to get in the fields again. The life I love is spreading potash for my friends, and I can't wait to get in the fields again. No, I can't wait to get in the fields again.
Welcome back to Ag Geek Speak, and welcome to a very fantastic episode. We have a very special guest with us today, Hudson Fuller, who, as of right now, beginning of May, is our newest full-time employee. So we're super excited to have him on the podcast to talk about his background. He is a recent graduate in computer science, and I'll let him talk more about his background there. And also someone that's working very closely with integrating ADAPT standard into ADMS. And Hudson's going to give us a lowdown on that and talk more about how we get data from our ag equipment into our computer. So we're really looking forward to this episode, and we know that Hudson will have a lot of fantastic information for all of you listening to the podcast. So with that, Hudson, do you want to give a little bit about where you're from, how you may have become familiar with GK technology in the first place? Because for those very keen observers, Hudson's last name may sound a little familiar to those that have worked for GK for a while.
Yeah, so I'm Hudson Fuller, as Jody stated, and I'm from Clark, South Dakota. And I was first introduced to GK at the first company retreat I got to go to, as we're a very family-oriented company, and the kids get to come along, and my dad works for GK. That was really the first time I got integrated in with Darren and Kelly and got introduced to them, and then got to my sophomore year of college, and I was looking around for internships in the area, and I figured I might as well talk to Darren because I knew I enjoyed the outdoors, and agriculture fit right in with that. But I also loved the nerd stuff with the computer science. And I talked to Darren, and he was willing to give me an internship for that summer, where my main focus was working on the first version of Adapt. And from there, fast forward to the next summer, I worked with GK again as an intern, also working on Adapt. However, it was a newer version of Adapt where they completely rebranded everything. And then following that, they decided to give me a full-time offer in December. I accepted it and started work here in January.
So, wow, there's a lot there, Hudson. That's a lot. So, my first question for you is, how old were you when you went to your first GK retreat? The GK Technology Inc. We go on a company retreat every summer. It's about a week long. It's our company meetings for the year, annual meetings where we really get a chance to like hash through everything for the year and where we're going to go for the future. And as Hudson said, that's when family gets to come in. But how old were you on your first company retreat?
I was 17. Yep. There's some of them have been there a lot longer than I have. It just never worked out the first couple of years of the retreat for me to get to go. But I got to go 17 right after graduating high school.
That's awesome. Okay. And what was your favorite thing that you got to do for fun on that retreat?
It was in Montana up in the Billings area, and we went to a natural land bridge, and that was my favorite destination that we went and did, and it was cool because I was able to throw our rock across the land bridge, get it across the whole canyon.
I like that reasoning.
Yep.
That's probably because you might know a little something about baseball and throwing a baseball.
Yep, I played college baseball for 3 years and played throughout high school and everything else, and at Dakota State University.
Awesome.
So speaking of Dakota State University, what did you major in? Like, I don't think my computer science description was really encompassing of like what your major was. What did you major in, and was that first what you started in? Tell us more.
Yeah, so my major was computer science, actually.
Oh.
Yep, you got it right. And then, no, that's what I started with. At first, I was pretty sure I liked computers enough to do it, but once I got into some of the classes where you actually were hands-on doing stuff with computers, I realized that I actually enjoyed doing it a lot. It didn't feel like I was in school, it just felt like I was learning something for fun.
Huh. We are certainly glad that we have you around here to solve all of our programming issues, and you think it's fun. That's great.
So what does that encompass? Like, do you learn a little bit about coding, about the hardware? Like, maybe what was your favorite class, like going through the whole computer science degree program? What was your favorite specific class out of that?
Yeah, so going through, it was pretty much all about coding and then the theory behind coding. Some classes where every week you'd have some sort of coding assignment where you'd have to make something. Other classes, it was more about, do you understand how this idea works, writing it out on a piece of paper. And then, as far as my favorite class, it was probably in my last semester. It was a software engineering class because it was all about one big group project, basically the whole semester. And it was my first real introduction to group work in a code system. But my two internships with GK, I was kind of off on my little lonesome working on the adapt because no one else understood C sharp, which is the programming language that adapt needs. So it was awesome to be able to work through different pieces at once to come together to a final project, which was an AI baseball pitch prediction analyzer.
Okay, I need to know more about that. But okay, so it was an AI baseball pitch predictor. So like the purpose of it was to predict which pitch you should use to trick the batter, or
So it was more about, say you knew you were going to throw a slider, and then you could figure out based on how hard it was, where it was at in the strike zone, and what the count was, it would figure out what the most likely outcome of that pitch was, whether it was getting put in play, a strike, or a ball.
so you could predict the strikes or the balls based on what pitch you were going to throw.
Yes.
How accurate was it at predicting at the end?
It was between those three outcomes, it was, I think, 80%, which is quite good for baseball because baseball, there's a lot of things that go into baseball, and lucky things will happen that you can never predict.
That's really interesting. So like you kind of need a database to do that, right? Like you're kind of building like a regression model and like predicting response. Where'd you pull data from? And like were there any factors that like came out that were really predictive that you didn't think they'd be? Or were you kind of limited on like what you were pulling in for?
Yeah, so there is a website called Baseball Reference, and it is for the nerds out there. It has everything from how much a pitch moves, exactly how hard it is, to how many times per minute it's spinning. And there is a library in Python that allows you to pull all of this data just almost instantly. And you can pull back to, I think it's 2012. You could pull every pitch from that season from a certain team, from a certain player. There's so many different ways that you could pull in the data. And that's where we struggled at first because we could export it in an Excel spreadsheet just to see it instead of trying to figure out by coding it what is actually in there. We thought that how much a pitch moved was going to have way more of an impact than it did. It ended up having almost a zero impact. It was way more about where in the strike zone that pitch actually was.
That's so cool.
And did I hear you correctly a little bit earlier that you just called yourself a nerd?
Yes.
That's awesome. I mean, we at GK actually like to classify ourselves as geeks, but that's okay. I have also, been known to be accused of being a nerd as well. So we're all in good company here. That's awesome.
Nerds make the world go round.
And so do geeks. And here we
Hmm.
are.
I love it because it's very similar to like putting together a science project, right? Like you have a
Hmm.
hypothesis of like what you think is going to affect the outcome, right? And then you test it. And in this case, you brought the data back, you looked at it, you built a model and found out that it was actually a different factor that influences it the most. But also, not on top of that, too, you also made a model that took everything into consideration and predicted what was going to happen. That's awesome. That's so
The other
cool.
thing that I thought was really interesting about some of the words that you just used, Hudson, is is where you were talking about how there's a lot of data that's out there. And, sometimes in baseball, there's some things that are just unpredictable and you just can't predict it. That really isn't that different from agriculture. There's a lot of things that we know. There's a lot of things that we deal with every day in the field, and we base a lot of our decisions based in previous knowledge and data that already exists. But sometimes there's things that just happen, right?
Yeah.
That's a great point, Sarah, because like, okay, so you've got all this data, right? And I think we've been talking in agriculture for the past, oh, I don't know how many years, ever since we've gotten yield monitors on combines, but we have a lot of data in agriculture now, and it's kind of piecing through and figuring out what actually has value and what doesn't. And that's kind of exciting with AI, right? Because instead of having to choose what factors or like what data you're pulling in to build your models, you can now kind of bring everything in as long as you have a library that's organized. And I think we'll talk about that with Adapt. But you can kind of look at all of it and figure out how that might predict final yield at the end of the season. And maybe that's a little bit too optimistic at this point in time, but that's cool. They think that's where the future is using artificial intelligence to analyze a lot of the stuff that we have.
So lots to talk about baseball and data and how we're doing predicting what's going on with baseball. So, but you've been really active with baseball. So tell us a little bit about like what exactly your history with baseball has been.
Yeah, so the first memory any of my family and me have with baseball is me wanting to play t-ball when I was 3 and we couldn't until I was 4. And I was so upset at that point in time. It was one of my sister's friends that was coaching that team, and it was hard for them not to let me play, but I had to wait one more summer. I did. And then worked my way up from t-ball to coach pitch, and then the first year where I ever pitched at all would have been probably when I was 12, and I only think I threw twice. And it was something the previous coach wanted me to pitch more, but I didn't want to. And then it just never really came up much until it got mentioned once I'd like to try it. So we tried it. It was okay, but it wasn't fantastic. Then we get up to the big field, the size that every team in America plays once you're about 14. And then it was, I got thrown on the mound against a bunch of 18-year-olds when I think I was 13. And my second time ever doing it, I had a line drive come back and hit me in the wrist. And it was that we went to the emergency room because we figured it was going to be broken. It hit me that hard.
Jeez.
Yep. Then kept working through high school. And then I think it was about my junior year, I realized there was a chance I could play college baseball and I was really interested in doing it. So I emailed the coaches at Dakota State because I knew there was a chance that I wanted to do computer science. And the DSU has the best computer science program in the area. So I was like, it would make perfect sense if I would be able to go play baseball there. I got an email back saying, we'll talk once you actually turn into a senior. Got an email back and went down for a visit and got my scholarship offer there.
Oh, that's awesome. So you got through college playing baseball.
Yes.
That's really cool. That's pretty neat. That's pretty cool. So, and is baseball still a part of your life today?
Yes. So I actually coach the high school team and the 16U team here in Clark. It's awesome to be able to do that and give back to I've played with some of the kids too because we've had to play 13-year-olds with the 18-year-olds. And then I also play for our local amateur team in the summers.
Okay. So baseball is still a big part of your life and everything
Yes.
else. So it was always kind of interesting because I know your parents followed you around doing to all your games and everything, and it was always kind of fun because I think Paul, your dad is Paul, and he used to take off and he'd bring his computer with and he'd map, on the road going all the way to see you and everything like that, and get a chance to catch up on the baseball and then come on back again. So it's interesting. We've been hearing about Hudson and his baseball as employees of GK for a little bit. Well, that's pretty neat. I think Jody was asking a couple questions about Adapt. So your first internship with GK was Adapt. And your second internship was adapt, but all different adapt, correct?
Yes.
So why don't you tell us a little bit about that? What is adapt? What does it do?
Yep.
Everything else.
So adapt is a standard that Ag Gateway has set in an attempt to unionize data formats across all of the agricultural software companies so everyone can say put it into a John Deere monitor and pull it back out and they'll be able to turn it back into the data they want to use in their own software system. The goal of it has always been full unionization, and a lot of different small companies have signed on to make it a possibility. There are not that many that actually have Adapt working at all. And it's because it keeps changing, which is a great thing because it needs to keep updating. So the first version of Adapt we'll call the Adapt framework. That is the one that I think it was 3 or 4 years ago, the idea was brought on to make a standardization. And Darren, he knew about it, he wanted to implement it, he just did not understand the coding language that it ran with. And then it happened to work out perfectly that I did for my first internship. So we worked through that first summer, and with the Adapt framework, it could export into multiple different file types, that being GeoJSONs, ISO XMLs, and then also an adapt file itself known as an ADM.
Okay, so when you're getting, and that's the as applied data then pretty much that you're talking about coming from, okay, from controllers getting into a standardized format that we can just bring in as generic file formats.
Yes. Yeah, and then from there, we got that somewhat working at the end of the summer. However, there was a few issues with it, and then we realized that Adapt had changed something in their code that made it not securely signed, meaning we could not release it to the public.
Hmm.
And then come to the next summer, we figure out how to fix that. I get that working, and then we realize that Adapt changed everything. They decided to get rid of the different types of files that Adapt would export to and just always export to a JSON file, which is it's not a bad idea at all because then you don't have a whole bunch of different file types floating around. But that meant I had to recode everything so we could export into that JSON style.
So backing up even before adapt, can you tell us a little bit more about like what the problem was and why is there this drive to have something standard? And I think in my head, I know sometimes we get asked as employees at GK to handle different information types, and I know sometimes I just can't open them right away, or like I don't have the right import. Can you tell us more about like what the problem at hand is here, and then how adapt and that framework is helping to get us closer to being able to view and use this data?
Yeah, so it's as simple as instead of having a whole bunch of different fruits and trying to make a big fruit salad, you just have one type of fruit set out at a buffet. There is no real point in any industry, but in the agriculture industry, it's been way different because there are more file types. There's the shapes and every single different file type associated with the shapes. There's every single one of those just leads to more space taken up on a computer and leads to more things having to get put on a flash drive or whatever else to get put into a monitor. If everything could get put in as one, our space would be a lot smaller and there would be no confusion within the industry. Everything falls under just a few file types instead of 50 or 100 that might be out there. Even though we don't use them, there are so many out there that are not used in our area of the world but might be in Australia or Asia or anywhere else.
So kind of like hydraulic hookups back in the day then. Like John Deere had their own specialized hydraulic hookups for many, many, many years. And you couldn't hook up, like if it was a chisel plow or something from a different brand, you couldn't hook it up to the John Deere unless you had the converter to convert the hydraulic hookup.
Yes, that's a perfect analogy.
Once we standardized hydraulic hookups, now we could hook up whatever equipment we wanted to whatever tractor we wanted without converters because we all had the same hookups.
Yes.
Every color would talk to every color.
Yeah, that is a perfect analogy for that.
Would this get us to be where like we wouldn't have to use the FOD importer for yield data, that kind of thing anymore? Or I suppose like there'd still be older controllers that would export like that, correct? Would this be something that comes out in newer controllers and we'd see that newer controllers are using the adapt standard, or is this like a standalone? How does adapt get implemented, I guess, would be my question. Like how what do things look like once adapt is implemented?
Yeah. So the idea is to not truly replace FOD because the older monitors and controllers, they will never get updated to adapt.
Okay.
But a lot of the newer ones, I know specifically with Case, they have the full implementation of adapt within their newer monitors. I don't know the numbers that controller or monitors are, but I know they use adapt, and that's why we've been pushing hard to get the adapt framework out because they use the ISO XML plugin of adapt so that it exports into a task data into that style format, but it all uses a format inside built from adapt.
So is that the would we be like exporting out like a GeoJSON then essentially through the adapt system that the case controller could read or
Case uses the an ISO XML file that has the boundary and it has the averages and certain other numbers associated with your prescriptions. And then it also exports a bin file. And that bin file has a grid associated with all of your different prescriptions for variable rate for that field.
That's really interesting. I guess I'm saying it's interesting because I've never thought about, because I think right now for exporting to cases, um, or like importing yield data, it comes back in like a CN1 file or like a. My point is, like even with like KMLs too, when anything's different from a shape file, I don't know how it works, right? Like the thought of like having a bin that has the grid of like all of the prescriptions, it just kind of blowing my mind right now. I'm just trying to think through like could you talk about like some other types of like file types and like how that's set up? Like could you walk through like in your computer language, computer science knowledge, can you talk about like what is a shape file? And then like what does a case prescription file look like, and maybe like another export type that you can think of? Because I think when I know what these things kind of act like, it helps me really understand like how to export things better out of ADMS, or like why I need to jump through a certain hoop to
Yeah,
get what I need to get done.
yeah. So we'll start off with a shapefile. And when I'm actually working with the data from a shapefile, I don't look at the shapefile. I I'm not seeing the boundary or the polygon style prescription. I'm not seeing that at all. I am just seeing the data in the back end of it. So we have a tool within ADMS that allows us to read in all of those points on the shapefile. Usually it is in different features. That is like in the back end what a shapefile has. Each polygon is not a polygon, it is a feature. And each of those features has so many different values associated with it. If it's relating to a prescription, they will have a some sort of numerical value. Say it's 112 pounds per acre or whatever it may be. And then they'll also have an extent, is what we call it, and that is the edge of that feature. So every little square has four numbers, and that is the lat long of each corner of that. And then in ADMS, we always read it in as northing and easting in the UTM style. Sometimes we have to transform it back into lat long to make it so that we can use that data across the world, not needing to know the UTM zone. That specifically has come up recently when I've been working with the field info stuff and trying to figure out how can we best actually get where this field is. But that's a different topic for a different time. And then the adapt ISO XML files, when you open up that file, the ISO file, you don't actually see a picture of the boundary. You will see probably 100 points or so that make up the edge of that field's boundary. Along with that, you will have the average of the prescription, like what the average pounds per acre in that field is. You will also have a default value and a out of field value. These values are in there, so if for some reason the controller cannot use the bin file, which is a file that just, you can't actually see the data in there. The computer can see the data though. It knows exactly what each point in that field the prescription can be. And then really another third type that gets used is a GeoJSON, which we also through Adapt will have the ability to export a prescription from. That comes out as two separate GeoJSON files in one folder. The one contains the basic information such as the boundary, the default rates, the out of field rates. And the other GeoJSON will be a very, very long JSON file that has a whole bunch of different boundary points in it, or prescription points, and then it will have the variable rate for each point within that field. And for example, one of the test fields that we have through GK, the Bloomhouse one, that one ends up at 25,000 different points of information that end up getting thrown into that GeoJSON file.
Wow.
But the controllers that read that can do it in an instant.
Wow.
That's amazing. So I suppose, like, as you get longer, if you have more polygons, if you've got more points where you're collecting data for each of those vertices, that's why the file size gets so big. When you increase the resolution or like decrease it down where you're going from like 3 meters to 2 meters or like 10 meters to 7 meters, you're increasing the number of data points that need to be collected for each of those squares. And I suppose for like older monitors, like we see in like the manual for exporting that matrix, right? Some of the older controllers can't handle that much data, right? And we've got to reduce that polygon size. But that makes sense if we've got data at all those points. That takes up more space and more memory with the computer to read those and process what that actually means to tell the spreader or the planter in the back what to do and how to vary the rate. Gosh, I'm so glad that you're talking with us about this because, you know, from our perspective, or like from me, especially as agronomist, I see a lot of these things on the front end, but I've got no idea how it's actually working in the computer to see these things and convert it into something that is, you know, making rates vary in the back. So this is really fascinating for me to learn from you, Hudson.
And not only making the rates vary, but making the rates vary in the way that makes, you know, the agronomist has the rates set up, but we want to keep the integrity of that prescription. And not every single export process can do that well. And so it's really exciting to hear about how this all comes together. And not only that, but to have the explanation of all of those different file types. That's pretty fun.
So we're going to cut it here, but we've had such a fantastic conversation, just getting to know Hudson a little bit better, learning about his background and how baseball has helped make Hudson a better computer programmer. But we've also talked a little bit about the ADAPT standard and some of the things that Hudson's working on. And it's been such a pleasure to have Hudson explain these things to us. And I know that we're going to do the same when we come back with Hudson in the next episode, in the second part of our talk with him. So thank you all so much for joining us today, and we will see you on the next full-length episode of Ag Geek Speak with GK Technology.
And at GK Technology,
We have a map
and an app for that.
No, I can't wait to get in the fields again.
Let the geeks at GK Technology help you with your agricultural data. Their agronomists know agriculture. When it comes to creating soils and zone maps to maximize yields in your fields, you can trust the people with decades of experience in site-specific agriculture. Everyone at GK Technology has a background in agriculture, so they know what makes a farm run, and they speak your language. The geeks at GK Technology have a map and an app for that.